I am so happy to be here. Look where we are. You know what I discovered today? Because I'm not very smart, I discovered that this conference is not a spring conference. That's so awkward. So awkward. Imagine my surprise. Aryan, my friend Aryan, local legend and Spring team legend, he was telling me, apparently the show predates Spring Framework. This show came before Spring. Does anybody else have any proof of that? That's cool. So how many years has this conference been running, do you think? 15. Oh, so it definitely does not predate Spring Framework, and we were both wrong. I go to him for the good advice, just like I go to the AI models. On occasion, they both hallucinate. That's okay. Anyway, I'm so happy to be here with you all here. I'm just, oh, look at this. We're in a wonderful place. This is actually going to be a little bit of a challenge. Normally, when I do these things, I do a selfie, a stage selfie. Are you okay with taking a selfie? Okay, now what if I do a pano? Because that's the first time I've ever had to do a pano. So just bear with me here. This is nice, okay? Just hold on. Just pretend like you're happy, okay? Just hold on. And I don't know if I can do how do you do a pano and a selfie? Oh, it's terrible. Okay, hold on. Let's just do regular selfies. We're going to have to do them in staggered sequences, okay? Just pretend, ready, steady, say open source. Okay, you guys need more coffee. Okay, open source. Ah, so good, so much better. Good. Open source. Awesome. Thank you very much. Thank you. I'm so excited. I'm gonna, people always ask me, why do you take those photos, Josh? What are you gonna do? And I'm gonna take those photos, I'm gonna show them to my daughter, and I will say, see, they listen to me. Anyway, my name is Josh. I work on the Spring team in my capacity as a Spring developer advocate, a Java champion. And look, we all do things that we're not proud of, okay? We all do things that we're not proud of. I am a YouTuber, okay? So you can find me on the YouTubes here. Whoa, what is that? We can find me on, copy. Okay, there we go. Paste. So you can find me on the YouTubes. And I just did a live presentation with API Oracle Aryan just a second ago, like 22 minutes ago, right? So there, it's not bad. It's not good either, the channel, except when we get good people like him on. But look, you can make worse mistakes than liking and subscribing, okay? Probably. So look, I'm really excited to be here, but I got to tell you, I was struggling with what we could talk about. I didn't know what we could talk about. We've only got a limited amount of time. What could I show you to demonstrate all the cool stuff on which the Spring team is working? And I thought, well, maybe we could look at the old Spring Pet Clinic. How many of you have seen the Spring Pet Clinic sample application? Not you, Aryan. Nobody. He was there. But the rest of you, how many of you have seen this? So this is a 20-something-year-old application, but it gets updated all the time. For example, apparently 45 minutes ago, so that's nice. And this is a sample application, and there's actually even a whole organization full of Spring Pet Clinic and Pet Clinics, Pet Clinici, whatever, just implementations of Spring Pet Clinic in terms of other technologies, And the domain is really good, but there's too much. We can't cover that in 45 minutes. There's just too many moving parts. We would never get done. That's a ridiculous idea. Ridiculous. So I thought, well, what if we could do something like that in the same spirit? Animals, pets, dogs, cats, these kinds of animals. Like everybody loves animals, right? Who's got a pet that they just adore, right? Who has a good pet, right? Pets are amazing. Animals are amazing. And me, I love all. I love almost all animals, okay? Almost all of them. Just not mine. My dog is the worst dog, okay? Not a good boy, terrible dog, just the worst. His name is Peanut, and Peanut, like I said, I don't know why he tries. He doesn't actually try. He doesn't know how. He's got no act. Dogs are supposed to do dog things. This guy, not so much. He's just not a good dog. He's the meanest dog. But we keep him in my home for 3 reasons, okay? 3 very simple reasons. 1, even terrible, terrible dogs deserve loving homes, okay? So that's a fact, okay? Obviously, so he gets a loving home, even though he doesn't love anybody. And then 2, I'm just going to be honest with you here, okay? It's ego. You see, in my home, my partner and our daughter, they both speak 5 languages, and I only speak 3.5. So if we didn't have that stupid dog, then I would be the stupidest in the house. That cannot stand. It will not stand, okay? It will not stand. And then just being real with you all here, just being honest with you, obviously, he's very cute, right? Very, very cute dog. Very, 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 very cute, but evil, okay? He's an evil dog, not a good dog, just the worst dog. And so Peanut, he reminds me of another dog that I learned about during the pandemic, whose name is Prancer. This is Prancer. So Prancer's owner was trying to find a new home for this dog, and she wrote this advertisement, this little solicitation to find a new home for the dog, telling people about this dog, and the ad went viral. She says, okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is, he's just not. It turns out there's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape that he has created in our home. If you own a Chihuahua, you probably know what I'm talking about. He's the Chihuahua meme that describes him as being 50% hate and 50% tremble. She continues, he was quiet and just laid on the couch, didn't bother anyone. I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home, right? Oh, this poor dog, the slander that this poor dog is taking, right? And she continues, she says, you can't live in an apartment or a condo unless you want him to bite your neighbors. We already addressed the men and children situation. If you have people over, he would need to be put away like he's a vacuum. And she continues, she signs off, oh, he's only 2 years old and will probably live to be 21 through pure spite, right? So who writes this about a dog, right? And I was thinking about it, I'm like, I would write that about my dog, right? He's a terrible, terrible, terrible dog, but also deserves a loving home. And just being real here, very cute as well, right? Very, very cute. I would totally pet that dog. That's a cute dog. And I think about this dog a lot, right? I think about both of these terrible, terrible dogs a lot. This dog was, by the way, eventually adopted. This dog went viral. So for example, here's BuzzFeed talking about Prancer, the viral nightmare Chihuahua, right? And here is the New York Times. Because again, there's nothing else to report, apparently. So Prancer, the demonic Chihuahua, finds a home, right? Again, a very cute dog, but also a bit of a handful. I think this would be a little bit of trouble. So I think about these terrible, terrible dogs a lot. And so that's what we're going to do, my friends, is we're going to build a service to support adopting terrible, terrible dogs. And we're going to do that by going, as always, to my second favorite place on the internet, start.spring.io. We have, as always, some things that we need to answer before we can begin our journey. First things first, what do we want to call our service? I want to call the service Adoptions because I'm amazing with names, okay? Amazing. I get that from my dad. He was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Again, amazing with names, okay? Amazing. And then we have the choice of what we want to use. Do we want to use jar or war? Obviously, my long-standing, overarching, guiding policy is to make jar, not war. So I use that. And then finally, what version of Java do you want to use, friends? Here, you have 3 radio boxes implying 3 different choices, but really there's only one, right? Obviously, you could technically use Spring Framework 3.0 or later with Spring Boot 3.0 or later and Spring Framework 6.0 or later with Java 17, but you should never, ever do so. We keep this just here. We keep this here just to find out who makes terrible life decisions, okay? This should never, ever be clicked, ever. In fact, I would argue it's software malpractice at this point. Java 21, at the very minimum, is where you should start because of the availability of virtual threads, which are a boon to scale and to all of us, really. They're just an amazing gift. So there's no reason to turn your back on them. But they somehow, as if they couldn't get any better, they already did get better in Java 24, which is why I say that you should choose Java 24. Java 24 is technically superior in every way. It is faster, more secure, more robust, more performant, more operations friendly. It is technically superior. It's also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production, okay? Don't do this. Be the change you want to see in the world. And remember, it's also better mathematically, right? Java 24 is 3 times as awesome as Java 8. That's just math. It's a simple fact, okay? Simple fact. So I'm happy with that. We're going to build a new application. We're going to bring in the GraalVM native image support. We're going to bring in Spring Modulith because I'm trying to build a modular code base so as to reduce the blast radius of change. We're going to bring in the Spring Web support, and we're going to bring in I could bring in Docker Compose support, but I already have a database running, so I'm going to make sure I have the Postgres driver there. I'm going to use Spring Data JDBC for my ORM requirements there, and I think I'm happy with all of that. So I've got Postgres, Spring Data JDBC, Modulith, Web, GraalVM. Let's hit enter, and we're going to open this up in our IDE. Now, friends, look, my friend Anton Arhipov, he did a, let me see, rapido. Okay, Anton did a presentation very awkwardly for me. He did a presentation the other day at this other conference, which is, it's okay, it's nice, but let's see, sessions, and here, where is that presentation here? Was it this one? Nope, come on, second day, here we go. I don't know how to bookmark things, apparently. That's the lesson here. So he did this presentation. He works at JetBrains, and he did this presentation called El Rapido, coding like Josh Long. Awkward. Very awkward. Because I am actually, at this moment, going through a bit of a spiritual journey, okay? I'm trying to learn Vim motions, like VI. I've been an Emacs person for 25 years, so now I'm trying to learn VI key bindings for navigation. So as a result, I'm not coding like Josh Long anymore, right? I'm very slow. So anyway, just keep that in mind as I hunt and peck and try and move through the code today, okay? So anyway, I've got the zip file here. I'm going to open that up. It's a zip file. You have an alias in my shell, UAO. It's aliased to a Java program that I use like a scripting language. It is a Java script. It is the only good use of a Java script, okay? Now, here's my application. We're going to connect to a data source, which, like I say, it's already running in the background there. So we're going to say Spring data source. By the way, is that big enough? Should I make that font a little larger? How's that, everybody? Can you all read that? Okay, good. I can read it from here, and my eyes are terrible. So, okay, localhost, my database, yeah. And we have this, and we'll say, see, watch this. Aha, Vim motions. Username, my user. And then password is secret. Okay, don't tell anybody that. That's just us. So there's my data source. I want to build an application to support adoption, so I'll go to my root package here, and I'm going to create a new module, a new root package called adoptions. And there, I'll create a dog adoption service. Yes, dog adoption service. And first things first, notice our first problem. First problem, what's this? Why is that public? Java doesn't think things should be public by default, right? Package private is the way to go. Do that by default, Kotlin, right? So here's this, @service, @transactional. There's my service. And I'm going to have a method here to adopt dogs, okay? So we'll say int dog ID, and, all right. That's awkward. You got to tell a person that, okay, fine, whatever. So anyway, we're going to have this. And it's going to be a service, and I'm going to use the service to adopt dogs. Well, what dog? I'm going to create an entity to map that dog to my schema. So I've got an owner, I've got the owner, the description, the name, etc. And this is going to be using Spring Data JDBC, which lets me use Lombok. And I just love Java records, right? Java records are awesome. So I'll use that there. And then I'm going to say dog repository. Okay, and I've got this table. Like I said, I've got a table there. Extends a list of CRUD repository managing. Okay, there we go. So there's this. Now I can reference that repository. I can say find by the ID, right? Dog ID. And there, if the dog is there, I'm going to update it with the new owner name. Okay, so that's it. I got the ID. I've got the name, and the owner is going to come from the client that makes this request, and I'm going to adopt this dog, okay? So that's the service. Maybe I create a simple controller here, right? So I'll create a controller, response body, and I'll just say dog adoption HTTP controller thing, okay? And, I can imagine having a delegation in effect. I'll say post mapping, dogs, dog ID, adoptions, yeah? And so this will become a request param, and this will become a path variable. There, and I'm going to just delegate. I'll say dog adoption service dot adopt dog ID, blah, blah, blah. And I guess I can just start that up. Let's try that and see if that's bought us anything. Okay, so now I go here, HTTP, 8080, dogs, and now I've got the data. Let's go look at the data here quickly. So I'm going to click that, open this up, refresh. And IntelliJ, by the way, these days is now smart enough to realize I've got this connection to a data source. Okay, click on that, click on that, click on this. There we go. Delete that. That's the old data. Don't need that for now. Okay, click on that. And there you can see we've got these dogs. And there's our dog Prancer. Okay, database, show database explorer. How do you? Nope. No key command. So there's our dog Prancer. His ID is 45. His name is Prancer. And he's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. Okay? And very surprisingly, no owner. What's that about? Right? So we're going to fix that. If everything goes to plan, we will fix that. So dogs, 45, adoptions, owner will be J Long. And of course, this is a post. So -- form, post, hit go. Go back over here, refresh, J Long. It's worked. I've adopted this terrible, terrible dog. Don't applause. It's not as nice as it sounds. So we have adopted this dog. Have we, though? Is that real? Can you take advantage? Can you like adopt a live animal in most places by updating one column and one table and one database? No, of course not, right? Of course not. There's more process involved, surely. So you can imagine, for example, that I might have to take this dog to the veterinarian, right? The veterinarian, of course, is a doctor for the dog, right? So I can create a new class here called wait, it's a dog tour. Okay, there we go. So that's what that is. So we'll say public void checkup int dog ID, and I'm just going to say system out checking up on blah dog ID, okay? And change that to be dog ID. There we go. So now I can use that service, such as it is. I can inject that service back over here in the dog adoption service if I wanted to. I guess I could do that. So I go down here, and now I can say dog tour dot checkup dog ID, and then reload. And now I go back over here and I rerun the same request, and there it is, checking up on dog ID. So it's done it, right? I've adopted the dog and I've involved that other module. The problem is I've now got a bit of coupling that maybe I don't want. One module injecting the other, one root package injecting a type from the other one. It's just fine. You can do that if you need to. But in this case, the checkup call, there's no return value. I'm not actually dependent on this. I need this to happen, but I don't care about the result of it. It's sort of orthogonal to what I'm trying to do, right? So maybe I can decouple these things. And the way I might do that is to use messaging. So I'm going to go ahead and create my first intentionally public event, okay? My first public type that I intended to be public. It's an event here. So there's that, and it'll be int dog ID. And I can now publish that from my dog adoption service. I can back out that change there, right? Get rid of this here. Okay. Goodbye, goodbye. There we go. So I can back out that change. And now, instead of doing that, maybe I can use the application event publisher to publish an event from one module to another, right? And this is a Spring framework mechanism that's been in there for almost 20 years, right? And when I do that, first of all, I can now back out the word public. It doesn't need to be there. I can make this an event listener, and this can become a dog adoption event, okay? So now I restart that, and let's see what that's bought us. Republish that, post. Go over here, checking up on dog adoption event. So I communicated from one module to another by publishing an event, but neither side knows about each other now. I'm using messaging as a way of decoupling systems, right, and components and modules. This is a very natural thing to do, but are we completely decoupled? Well, I don't know if we are, right? Like what happens if I do this? If I do thread.sleep, right, 5,000, and I say throws exception, and then I do that, restart. Now, I make the same request, and you can see it's waiting 5 seconds, right? So I published the message from one component module, one root module, one package, to another, and I waited 5 seconds. I'm still temporally coupled, right? I don't want that. Are there ways around this? Yes. I mean, I could do, for example, @async, but if I did that, this would get invoked in a separate thread, which is okay, but what if I have some transactional state in there? I'm no longer participating in the same transaction as the original module. Maybe that's what I want, maybe it's not. But what happens if I pull the power on the plug? I pull the plug from the machine, and now the server goes down, and it hasn't finished whatever it was doing for 5 seconds. I've got a problem, don't I? Right? So I want to make sure that this gets handled eventually. Spring Modulith gives you runtime support for this kind of stuff. So I'm going to use a nice feature here called Application Module Listener. This comes from Spring Modulith, and it pairs, like a Heineken and Bitterballen, very nicely with some configuration here. We say republish outstanding events and restart, and Modulith initialize schema is true, okay? So I'm going to restart that, enable that, and now I go over here, make the same exact request. It returns immediately, and 5 seconds later, we'll see it print out this. Here we go, checking up on that. And if we go to our database tables, here, refresh, go down, refresh again, refresh, please. My database, public tables. There's this new table called event publication, okay? And this table has the ID, the listener ID, okay? The event type, the serialized representation of the event, the publication date, and the completion date. So if I do that again, refresh, there's no completion date yet, right? It hasn't finished. 5 seconds later, it will finish, and there you go. So now I've got the completion date. So this is called the outbox pattern. If you have some non-transactional resource, like Amazon S3 or an FTP server or another microservice or whatever, and you need to make sure something happens, there's no JTA for REST, right? There's no like JTA for S3 or something like that. So the way you can reconcile that non-transactional state is by using a transactional ledger, like a SQL table. And as long as that completion date is null, then you want to keep trying. And so Spring Modulith will actually do that for you. So let's go ahead and rerun this again. Stop the process, right? Goodbye. Okay. Now if I go over here, well, actually, IntelliJ is here. Let's do this. PG password, okay, equals secret, psql minus u, my user, h localhost, my database. Okay. Select all from event publication. There you go. You can see there's no completion date here yet. So now restart the program, and then we just keep polling. Still nothing. Still nothing. Still nothing. Okay. 5 seconds. There you go. That one looks like it finished. So now this eventually got reconciled. And I restarted the program, and it republished the missed message, right? So you can do this yourself. You don't have to wait for restart. You could create a thing that runs when the application starts up, like this. You could say, you incomplete me, okay? And then use that here, like this, to listen, or to republish, rather, the missed incompleted messages, right? And you get a predicate here, and you can look at the event, the completion date, all that kind of stuff. So you don't have to use our thing, certainly. You can do your own, but I'm just saying there is that mechanism to republish missed messages. Great. So now we've got this thing, and we've got eventually consistent state, and our two code bases, our two root modules, DOGTOR and Dog Adoption Service, are separated by this message. They're no longer coupled to each other. I think we're doing a pretty good job. We've written our code in such ways to be modular. What does that mean, though? When I say modular, I'm definitely not talking about OSGI or Java Platform Module System or anything like that. What I'm talking about is writing in code in such a way as to reduce the blast radius of change. I make a change here. It should not shake the whole cobweb and disrupt everybody else in the organization. You want to write and minimize the scope of your change. And you do that by taking advantage of information hiding. Remember, this is Java. It's an object-oriented language. You have information hiding. The whole point of information hiding is to hide information, right? That's the whole, you have that, right? If you want everything to exist in a flat global namespace where everything is public, just use C, you know? It's easier. Just be honest with yourself. Don't torture this poor language that's done nothing to you by making everything public. That's the first thing. Sometimes you can't help make it public, right? Sometimes even within a package, you have nested package dependencies, and those nested dependencies, nested packages, you need those types to be visible from the root package. Fine, it has to be public, but you still don't want to have that stuff used accidentally, inadvertently, in other root packages, right? Leaking dependencies from one module to another. So how do you validate that? Well, as with all things, you write a test. So let's go over here to our test code. var am application modules, right? Application modules of, okay, and it'll be adoptions application.class. I'll say am.verify. Heck, I can even print out the modules. I can even document the modules, right? So, and I can run this test now. Here we go. And you can see the test is green, right? Isn't that nice? Nice and green and clean. And if you scroll down, you can see that Spring Modulith knows about the logical name of these two different modules, right? So vet and adoptions, and here's the dependencies and so on. And it knows so much about the relationship of these two different modules that, in fact, it can actually document everything for us. So if I go to Spring Modulith docs, click on that, I have a plant UML diagram that in turn results in an architecture diagram that I can actually version control, right? This is just a C4 component diagram, a component boundary diagram based on Simon Brown's style right there. So this is very convenient. This is much better than when you log into some wiki page and there's some diagram that is like from the Stone Age that no longer looks like the actual code in production. This gets updated with every single run of your code. So this is a much better situation. I think we're doing good. We've got ourselves a nice, clean, modular code base. Now what? How did we find this dog? Well, I read about him in the news, right? Like, he was in the New York Times. That's how I discovered this terrible, terrible dog. But how do most people discover dogs? Hopefully, they don't adopt the dog they see in the news for being terrible. Hopefully, they go to a shelter and talk to somebody or whatever, you know. So we want to support that process as well. So back to the lab again, right? Start.spring.io, and we're going to build a new service here called Assistant, yeah? And this Assistant, you know, it's going to help answer questions about dogs available in the shelter. So we're going to use a little AI. We'll bring in the GraalVM native image support. We're going to bring in the web support. We're going to bring in Open AI, but there's lots. We're going to use Spring AI. How many of you have heard of Spring AI? It's going to be big. You just watch. It's going to be good. So we've got all this stuff, all these different modules and models. Spring AI just went GA, by the way, just May 20th, right? We went GA. So long in coming. I'm so happy. Anyway, we have different modules. I'm going to use the OpenAI support. You can use whatever you want. Gemini, Bedrock, Olama, whatever. We have dozens, and like more than 20 different models are supported there. So we'll use OpenAI. We're going to also use, I'm going to use a vector store. So there's lots of different vector stores. You probably already have some of these installed. You can use Oracle, you can use MongoDB, Elasticsearch, or Cassandra. All of them are good. I'm going to use PG Vector since I'm using Postgres at the moment. You know, I also want the chat memory. I want the JDBC chat memory support as well. So there, that's my basic, my setup there. Oh, we also want the web support, and we want the Spring Data JDBC support. Okay, and enter. Now, the first thing I'm going to do, my friends, is I'm going to open this up in my IDE. Okay, so Assistant, let that load. And then the second thing I'm going to do is, while that's loading, I'm going to do something terrible, something that you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. So here we go. Copy, go over here to the Assistant, okay? Paste, right? There we are. There's that. Good. Paste that in there. Good. So now I've got my Assistant, and what we're going to do is we're going to build a simple controller to answer questions about the dog. So Assistant controller, and I'll have a post mapping endpoint, and I'll say, you know, let's say dog. We'll have a user context. How about that? And then we'll say Assistant, sure, or maybe even dog's assistant. I don't know, whatever. So string Assistant, and actually that is the worst auto-completion of all the ones you could have given me. So request param, string, user, there's that, okay? No, path variable, there's that. And what I want to do is I want to use the AI chat client. So this is if you've ever used any of the other clients in the Spring ecosystem, this should feel fairly familiar, right? So I'm going to inject the builder, build it like that, and we'll configure this chat client as we work. It, in turn, is going to talk to a chat model, which is going to be enabled because we have an OpenAI API key. Now, friends, before I got on stage, I already exported an environment variable, and that environment variable is providing me the configuration. Trust me, it's already been done, and forgive me for not leaking my API key, okay? Now, we're going to say return this.api.prompt. We're going to pass in a question from the user. So this is a question that the user might have about dogs in the shelter. So there's that. We'll say, give me the response, and actually, I can tease this apart. We'll come back to that in a bit. So call, and I want the content back as a string, okay? So let's go ahead and start that up and see. Oh, it's going to run on the wrong port. Here we go. Okay, go down. Home, nope, in, good. Vim motions, by the way, so, you know, don't be jealous. Okay, here we go. Start. Now, HTTP 8081 JLong dogs assistant, okay? And then the request param, the question equals, my name is Josh. It's not really a question, is it? But let's just see what that gets us. What did I do? Oh, goodness. Computers, what even? Thank you. OK, so here we go. Take 5. Method not allowed. Did I make that as post? I did. I blame myself. OK, take 7, 502. OK. Nice to meet you, Josh. How can I say it? We're friends. We're friends. It's really good. It's really good. OK, let's see. They say that software engineering is a lonely life, but I've already made a friend. What's my name? I don't have access to personal information about individuals unless it's been shared with me during our conversation. How could you forget? It was just here, right? I have this effect on people. Not sure what it is. But nonetheless, it's already forgotten me. Typical. And so we need to give it some memory. This is a thing. When you talk to an AI model, it has no memory. So we need to give it memory. One way you can do that is by configuring an interceptor that pre- and post-processes requests using the AI client or the AI chat client. So we're going to configure a bean to persist our chat as a transcript, in effect, in the database. Okay. So first things first, I'll say JDBC chat memory initialization is true or always or whatever. Yeah, there you go. And then I will create this bean. Now this, it's probably going to be fine. Don't cry. Just don't look away, okay? So here we go. This one, var JDBC equals JDBC chat memory repository dot builder dot build. Got to pass in the data source. Don't forget that. Data sources, okay? Got this. Fine. Almost there. Okay. Now we want the prompt chat memory advisor. So prompt chat memory advisor is that. We want the builder. And then this, we need the message window advisor. Okay, so message window chat memory dot builder dot build. And then that in turn takes the repository there, right, okay? And then this takes that. So easy. Look at that. Rolls right off the tongue. Okay, so I'm going to inject that bean here and plug that into our code. So we'll say there we go. And that advisor, we're going to use that to configure the behavior. It's going to pre-process all the requests by logging, in effect, the request. Now, how's the client going to connect this particular request for the particular user? Well, you configure it as you make the call. So I'll use the advisors, and I'll say a.param chat memory dot conversation ID corresponds to this user, right? And you can imagine instead of using a path variable, you had the Spring security context, for example, instead. You can just get the current authenticated principal dot name, okay? So now take 502. My name is Josh. Okay, so far so good. What's my name? Haha. Easy. We're friends. Thank you. Thank you. I did all that myself, except for the thousands and thousands of lines of code that somebody else did. Okay, so we've got our memory. I think we're doing pretty good, but the problem still remains. This is effectively an open hole directly from the client to my OpenAI account, right? They're just gonna, some kid could come along and get their history homework done by asking my AI endpoint questions, right? We haven't really given the model a mission. It doesn't know what it's supposed to be doing. It's just answering any question we give it. So the way you give it a mission is by giving it a system prompt, okay? And I happen to have a system prompt here. So desktop talk, system prompt, there's that. Okay, I'm going to copy and paste. I'm going to cat that and then copy. That's wrong. I'm sorry. Better. So take that and paste that here, okay? Here we are. So there you go. You can see it says, you are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, San Francisco, and London. Sorry. Nope, wrong one. Close enough. There you go. I know where I am. I was just testing you. Just testing. Okay, so there we go. There's our system prompt. It's better. Let's go ahead and restart that. Okay, so now, take 5. So where's my question? Here we go. Okay, do you have any neurotic dogs? Okay. Okay, I'm sorry, but I don't have any specific information about neurotic dogs available for adoption at Pooch Palace. So it knows what it's trying to do. It's got a mission. It's acting in terms of that mission. It doesn't have any information yet, but we're close, okay? Next, I want to give it access to our data. Our data is in a SQL database. These models, they have a thing called a token count. It's a proxy for the complexity of the request. I could spend all my tokens by sending my entire database, but that would be very inefficient. It's the principle of the thing, right? I don't want to send more than I need to. So instead, I'm going to subselect only the reasonable data by putting it in a vector store. And remember, I've already got a vector store here based on Postgres. I'm going to use Postgres as a vector store. So I'll say PG vector store initialize schema is true. And then I'll inject the Spring AI vector store abstraction. And what I'm going to do is I'm going to also inject the dog repository. And I'm going to read the data from the dog repository and then write it out to the vector store as documents. So for var, there you go. I'm going to create a document. Here we go, new document. This is a Spring AI document, ID, name, and description. Whoa, come back. And there's no schema here. I'm just putting arbitrary strings in there in whatever format I want. The trick is just to be consistent, okay? So put that in there, and then vector store.add list.of, and then we'll put the doc. No, that doesn't feel right at all. Document. Okay, there we go. Very good. Okay, so there we go. There's our document, and we want to tell the model again to know to talk to that. So we'll say new question answer advisor, passing in the vector store. Okay, so it's another filter, if you will, going to the database. Okay, so when the program starts up, it'll take a little while because it's got to initialize. What just happened here? Unexpected token extension. Do I have? Okay. Let's see, Docker, PS, PG vector. Well, that's fun. Create extension if not exists vector. Create extent. What's the issue with that? Is that working? That's a new issue. Hold on. Wait for a second. Sorry, what? It tried H2? Oh, did I forget to put the PG vector database in here? Thank you. Oh, I did. I put it right here, didn't I? Did I forget to add it? Spring JDBC. There it is there. How did I? Oh, it's right there. That feels like it should be already there. Okay, hold on. Oh, I don't have the data source. Yes, still the same problem. Again, more copying and pasting. Look away. So sad. Okay, here we go. There we go. Take 5. This will be fine. Don't worry. Okay, now we're cooking. So it's going to start up, and it's going to, thank you, by the way, for helping me catch that. We would still be here tomorrow. So it's up and running. It's going to initialize that. It takes a little while. Look, all that initialization, all that vectorizing takes a long time. It's very inefficient, right? It's using some very, very complicated maths to do that. So I am going to comment this out. I'll say if false, and it won't rerun each time. But now I can go ahead and ask that same query. I can say, do you have any neurotic dogs? Okay. And it says, yes, we have a dog named Prancer, who's described as demonic, neurotic dog that is known to be man-hating, animal-hating, and children-hating. If you're interested in learning more about Prancer, feel free to ask. Okay, we found the dog of our dreams, or, nightmares. So good, it's working, okay? Now, what's the natural next step? I think we would want to adopt that dog, obviously. Who wouldn't want to, right? So what we need to do is to give our model a little executive agency, to give it the ability to act on our behalf. And we do that by giving it access to our business logic. So what I'll do is I'll give it access to tools. So let's create a little service here, dog adoption scheduler, okay? And I'm going to give it the ability to schedule a dog for pickup, okay? System out scheduling this dog for pickup or adoption at, and then we'll give it an instant here. So here we go, var I equals instant dot now dot plus 3 days, okay, dot to string, okay. So that's a date in the future that we're going to allow people to come and pick up this doggo when they are interested. And how are we going to tell Spring AI about it? We're going to create a description around the tool annotation. So schedule an appointment to pick up or adopt a dog from a Pooch Palace location. Okay, so there's that. And we got to annotate this with a tool param. Okay, the ID of the dog. Maybe I'll even pass in tool param the name of the dog, okay? The name of the dog, okay? Name and dog name, sure. Okay, there we go. And I'm going to say picking up that dog, this one here, dog name, voila. So now we're going to give that tool, we're going to give our model access to that tool here. I'm going to go back to the constructor, and I'll inject that here. And over here, I'll just say default tools, scheduler. Restart that, and now try the same exact request again. Do you have any neurotic dogs? Okay, Great, got Prancer. Fantastic. Fantastic. When can I schedule a pickup from the Utrecht location? Pickup for Prancer from the Utrecht location, okay? Like that. Okay, June 8th. That's 3 days from now, right? Today's the 5th. Click on that, and you can see it called the tool. So we've got now tool calling. You've given it the ability to invoke tools and talk to your systems as it deems necessary. And you did it by, as your mom always told you to do, using your words, okay? Whenever you're frustrated, use your words. And that's what we did here. This is why it's very important to be articulate when you write code these days. Documentation, right? They always said you got to write your documentation. It's so useful now. You're documenting it for the AI. Okay, so we've got our system, we've got our assistant. I think it's now time to get this thing deployed to production, or at least we can just focus on one of them, okay? So we've got to answer a few questions here. Here's my adoptions service. We've got a few things we need to focus on before we can get this to production. First of all, is our code efficient? Is the code efficient? Well, it's Java. Of course it's efficient. Of course it's efficient, right? You've probably seen this. This is a blog from some Portuguese back in 2018, before the COVID pandemic, or BC. And this blog asks the question, which programming languages use the least electricity? And they talk about all the different languages that use electricity, and the results, I think, are not all that surprising. So you can see that C is the most energy efficient. It's the most energy efficient for machines, not for people. Definitely not for people. Rust, zero cost abstractions, well done. C++, tui. Ada, who cares? And then Java, okay? Java is top 5 most energy efficient already. It's also a virtual machine. You can see it's got a V there as opposed to the compiled bit right there. So it's already very energy efficient, and yet it's a virtual machine, right? It doesn't have a compiler per se. One wonders, though, what would happen if Java did actually have a way to compile to native code? That's called foreshadowing, my friends. Just keep that in the back of your old noodle, okay? Okay, so great. And you can see that the list goes on. I mean, you've got other entries here. Here's C#. It's pi. It's nice, right? You've got Go, away. You've got these two terrible languages. The less said about which, the better. Look, never apply the lessons of the real world to JavaScript. Every time you do, you will be disappointed. In normal computer science and physics, when you take a compiler that optimizes away certain code paths, that results in faster executing code. And yet somehow, this is 4 times less energy efficient than that. Makes no sense. It's just JavaScript sense. Don't think about it. Moving on, okay? Nope. And then these two. Look, JRuby is Ruby implemented in Java. And Ruby is Ruby implemented in C. And JRuby, because it's built in the JVM, is almost 1/3 more efficient than Ruby. The JVM is boss sauce software. Don't let anybody tear it asunder. It's an amazing piece of kit. So yes, our code is efficient, okay? Is it scalable? Remember, scalability is very important, right? To the extent that I can do things quickly, scalability is very, very important. But obviously, a lot of times, the scalability that you have to deal with is by waiting on other things. So I'm going to show you a quick example of virtual threads here, okay? And this is going to be a demo that I stole from my colleague, Cora Eberkleit, who's a lot smarter than I am, so I steal her examples. This one with her permission, but lots of other ones probably without. This one is a simple controller, okay? I'm going to simulate a long latency, such as that as you might get by calling another REST API, or, for example, a chat model, okay? So I'm going to say virtual, this is Cora Eberkleit demo controller. This is her demo. She's a lot smarter than I am. So delay, and I'm just going to delay a request to a backend service. So I'll use the REST client here, HTTP, inject that into the constructor, and fabricate it like so. Okay, there we go. And I'm going to say this .http.get.uri HTTP. I'm going to call localhost /delay/5, okay? And that's going to wait for 5 seconds before returning that endpoint I'm going to call, okay? And you can see that. I've got that here, I think. Desktop, HTTP, talk, HTTP bin, okay? It's going to start up, and it's going to run on port 80, right there, localhost 80. So if we go to localhost 80, delay 5, this response, this endpoint will simulate like responding 5 seconds later, like for some long amount of time. And that means that we, as we make this request, are stuck in a thread. Now, obviously, I want this to simulate what we get in production. So what I'm going to do is I'm going to lower the number of threads here. And we'll talk about why that is in a second here, OK? So first, let's kick off the test, a little benchmarking. So we're going to make 40 requests, concurrently 20 at the same time to localhost 8082/delay, OK? And that is 8082, right? Yep, here we go. So that's going to launch 40 requests with as many as 20 at the same time. I'm using regular traditional blocking I/O, no virtual threads here. And the reason I limited the number of threads here is because my machine is freaking amazing, okay? I'm just going to be honest with you here. This machine, freaking amazing. I can run Slack and Chrome at the same time. I know. Thank you. Thank you. It's an amazing machine. I started working in IT in 2002, and at the time, they had us take these giant pizza box servers, and we were meant to install Solaris or Linux, and then take them to the data center, which are big, refrigerated rooms, we did do that. But first, we installed Doom, and we played Doom, because when else would you get to play on a $20,000 machine like that? The machines in production were amazing. The machines at our homes were terrible. Now it's the opposite, isn't it? The machines you have in production are virtualized, you get 1% of a vCPU or whatever. So I'm limiting the number of threads to simulate what we might get in production. Now, I'm going to refactor this code to take advantage of virtual threads. It's not going to be easy, but if we put our mind, OK, it's done. So here we go. Let's go back over here and then do the same exact test, OK, with virtual threads in play, OK? So 40 requests with as many as 20 at the same time. OK, take that, go over here, and yep. OK, so up there, call that yuck. OK, down here, call this yay. The virtual threads version took half as much time as without virtual threads. We got the slowest going about 5 seconds, which is what it should be, but over here it's almost 300%. Right? And the average was 7.5 without virtual threads. Down here, the average is just slightly slower than the fastest. Virtual threads basically doubled our requests per second and halved the time it took to process all those requests. That's free scale. Turn that on, deploy Java 21 or 24, and you get scale. So yes, our code is scalable if I go back over here and do the important thing, right? So virtual threads is enabled true. Great. So now virtual threads, good. Is our code fast? Well, of course. How many of you have seen the 1BRC challenge, right? This is our friend, Gunnar Morling. He asked people back in January of last year to write a program to load 1 billion rows of weather station telemetry data and to do it as fast as possible. How long do you think the fastest entry took? How long? Some people say 5 minutes, 30 minutes, whatever. Well, 1.5 seconds, right? 1 billion rows of weather station telemetry data, and you compute statistics. And it took 1.5 seconds. Now, most of these are using GraalVM, okay? So what GraalVM really helps you kick it into overdrive when you want to go fast. The only problem is GraalVM does add time to the build, okay? So I get really bored really easily waiting for these things to finish. And I finally understand this cartoon here. This is a cartoon from XKCD. The boss says, hey, get back to work, compiling. Okay, I get this joke now. I thought this was for the C++ people, but no. Here we are, right? And the compilation does take a long time. And I got really bored, and I said, OK, I would like to hear elevator music while I'm playing. So I went to Oracle. And I said, Oracle, please play elevator music during the native image compilation. And I said, I already hear elevator music in my head when I do these compilations. I'd just like everybody else to hear it too. And I got some great responses. This one says, use this elevator music. Great idea. This person said, why not use beeps like a microwave? That's a great idea. Can you imagine? You start compiling, you walk away, ding, code's done. Come back and be ready. And then we got this response from my friend, Dr. Fabio Niepaus. He's a researcher on the GraalVM team at Oracle Labs, a PhD graduate. And he very kindly says, thank you for your feature request. Josh, the problem with with playing music during the compilation process is that it's just fixing the symptoms, and we've been still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Go on. I have prototyped a -- Josh long mode. So you click that. you click that, you run the native image compiler, now you're hearing music, you don't know why, who did this to you, where is it happening, why is it happening to me? Now it says music brought to you by Josh Long. Okay, you're calm like a cow, but still, you've got nothing to do. So now you've got something nice to look at, right? It would be a picture of me in the spring shirt. So I've been waiting for this to get merged for a while. Over the holidays, our friend Richard Fishner, he put together a plugin, a Maven plugin. Okay, and this Maven plugin plays music while you run the Maven build, okay? And it's based on this, right? This GraalVM issue from Josh Long. So we're going to use that plugin here to make things just a little bit easier, to put us all in that compiling kind of mood, okay? So go down here, go to the plugins, here we go, paste that in. Make sure you use 1.0 or later, except nothing less, so 1.0, okay? And now let's compile this into a GraalVM native image. Oh, I'm so excited. So skip tests, p native :compile. See, it takes a fair amount of RAM. It's a percentage of a machine. That's 1 slack of RAM right there. So it's a fair amount. So anyway, we've got this. Target. Adoptions. Here we go. Oh, the port's already in use. Let's stop that over here. OK. There we go. Take 2. There's our application in 84 milliseconds. Up and running. Much more importantly, though, here's the RAM. So measure that, PS minus O, RSS. And there's the RAM. That's measured in kilobytes. So divide by 1,000, you get megabytes. That's 89 megabytes. Now, friends, 89 megabytes and 84 milliseconds. I'm going to do something just to demonstrate how cool that is by doing something I would never, ever do in polite company. I am going to launch Chrome. OK, now, here we go. CNN.com. Don't look at the news ever. OK, here we go. Wait for it. Still loading. JavaScript, by the way. Wait for it. 1 gig of RAM. 1 gig of RAM for 1 tab, 1 stupid JavaScript app that took seconds to load. Whereas I can load a Java app that has AI and observability and security and modularity and is well written and is lightning fast and takes less than 1/10 of that in RAM. We live in an amazing time, my friends. We live in an amazing time. There has never, ever been a better time to be a Java and Spring developer. And now I have 2 terrible dogs. So thank you so much for your time. I appreciate it. Thank you, thank you, thank you. Who learned something new? Who learned something new? I appreciate you. Who learned something new? Something new. Okay, good. Who had fun? Okay, good. Please vote so they invite me back. Thank you very much. Let's make this great. Thank you.